Hello again. We're going to do another practice problem. This is out of your textbook, problem 2.13 on shear strain. The problem here states a thin square plate is uniformly deformed as shown in the figure. Determine the shear strain after the deformations at corner R and corner S. So if we look here, this is corner R right here, and this is S right here. So this box right here, these two edges, that was before the deformation, and then after the deformation it moved up this way. So what occurred is now we have a triangle here, right, that we can take and use our knowledge of trig and say this is R, this is S, 25 millimeters and 120 millimeters, and I'll call this alpha. So what's alpha? I'm going to just use trig and say this is opposite over hypotenuse, so alpha equals, what is it, sine inverse of 25 over 120. So make sure also make sure your calculator's in radians. So sine of 20 divided by 120, and I get 0.20987, so 0.209870593. I just carried out all these decimal places. You don't have to do that on the actual problem, but this is our in radians, so I'll just say rad. So this angle is how much it's moved, how much we've increased. So if we look, this is the angle increase right there. And so, but we need to remember that it's in addition to what we had here. And what is this? This is 90 degrees. And so since we're in radians, this 90 degrees is pi over 2. So we can say that our theta equals pi over 2 plus this new value that we just got, 0.20987.1. And so now we can go and use the formula on page 40 of your textbook. I recommend you read it. List the formula. We have the strain, which is gamma xy equals pi over 2 minus theta prime. Well, I guess we could call this theta prime. It's theta or theta prime. So solving this algebraically, we can then say theta equals pi over 2 minus gamma xy. So setting these two equal to each other, since we have, I guess it's theta prime, set this one and this one equal to each other because they're both theta primes, then we can state that pi over 2 minus gamma xy equals, this here is pi over 2 plus 0.20987 radians. And then solving this for our shear strain, we just get, because these cancel, we get gamma xy equals negative 0.20987 radians. Now this negative value, don't get confused on this. That negative value, if you again read your textbook, page 40, it states a positive value for shear strain means that angle theta prime between x and y decreases in the deformed object. Now what we can say is we have a negative value So that means our angle has increased, right? Which is this blue angle that we have here. It's true. Verified that we have the correct answer. So this is for R. Now because of the geometry of this, right, this line here, we know that this angle S is going to be the same angle, theta, just in the other direction. So S then equals pi over 2, we can say pi over 2 minus our gamma, right? Because that's still theta, it's the same one that we had here. And we had the negative angle, so it could be pi over 2 minus gamma equals pi over 2 minus 0.20987. Solving for gamma, those cancels, the negative cancel, and we get gamma equals 0.209871 radians. And those are the angles, or the shear strain at points R and S on this deformed object.